Hello guys, thank you so much for watching this video. We're going to begin chapter 3, skipping section 3.1 until we meet as a class together, so we can go into more depth and I can give better instructions when I actually have you one-on-one. So section 3.2 is solving systems of equations algebraically. So if we don't remember what algebraically means, it means basically without graphing and using basic algebra skills like adding, subtracting, substitution, things like that. So a system of equations is when you have two or more equations and they contain the same variables. I'm pretty sure most of you have already learned this, and this will act as kind of just a review, maybe with a little bit of more difficulty. So the two methods we're going to discuss today are substitution and elimination. So substitution means I replace one variable in terms of another variable. So if I have x's and y's in one equation, maybe I can replace the y's with something in terms of x. And elimination means that in both equations, I'm going to work towards eliminating one of the variables, the same variable from both equations. And that will leave me with one variable to solve for. So the first method is substitution. So if I give you a system of equations, 2x minus 3y equals negative 2, and 4x plus y equals 24. Now the solution, when you hear solve the system, yes, you're solving for x and y, but what that actually represents is the point where the two lines cross. So if you were to graph them, and it said solve by whichever method, what you're actually solving for is the ordered pair where the two lines intersect. Now we do know that it's possible for lines to intersect one time. It's possible that two lines never intersect if they're parallel. And it is possible, but rare, that the two lines would intersect infinitely many times because they would be on top of each other. Okay, so they'd be the same line. That happens rarely, but it does happen sometimes that the two lines wouldn't cross at all, or most of the time, the lines cross exactly one time. And we'll encounter these two situations where they never cross, or they cross infinitely many times when we get back together in class. So looking at this first example, it wants us to solve the system of equations. And we're going to solve by substitution. So when you look at the x and the y in each of these equations, one of these variables, one of the four that you see, is very easy to solve for in relation to the other three. And I'm hoping that you see that it's the bottom equation, solving for y, because I can simply take over the 4x, and then I have y alone. So you don't always have to solve for y. I would look at whatever variable is the easiest to get alone and work that way. Most students are just trained to always solve for y because that's how you've been brought up, but solve for the easiest variable. In this case, it happens to be y. So now I'm going to take this equation and I'm going to substitute it into the top equation and replace the y with negative 4x plus 24. And let's solve that. So 2x plus 12x minus 72 equals negative 2. That becomes 14x. Adding 72 becomes 70. And dividing by 14 gives us an x value of 5. Now we can substitute that x value of 5 into either of our original equations. And since we're pretty confident that we solved this equation correctly for y, we could substitute it into that red equation. So negative 4 times 5 plus 24. So that's negative 20 plus 24, which is 4. So that means if these two lines were graphed, you would see them cross, at the ordered pair 5, 4. Okay? The only thing that could make substitution or elimination any more difficult is if you had fractions or decimals, which we will again encounter when we come to class together. We'll do some more difficult ones then. But for now, just understand that that's how we do substitution. And again, I'm pretty sure that most of you have already done them. Actually, we'll do one more example, and we'll do one with a fraction so that you don't feel all crazy when you see the fraction. Okay, and we're going to do it with substitution again. So there's our first equation, 7x plus 2y equals 16, and negative 21x minus 6y equals 24. So when I look at these four variables, the 2x's and the 2y's, to me, the easiest one to solve for is the y in that top equation. That's just me. So since I'm the one doing this, I'm going to actually do it that way. So I'm going to take the 7x over and divide out the 2. Leave the fraction. Don't be intimidated by it. Chances are it will probably cancel and make a whole number when you substitute it back in. So here's my equation, negative 7 over 2x plus 8, and that's what we have equal to y. So since we used the first equation to solve for y, we're going to use the second equation as our substitution here. And substitute that negative 7 halves x plus 8 into that equation. And don't fear when you're distributing this number into this fraction here. We know a negative times a negative is a positive. Instead of doing 6 times 7, do 6 divided by 2, which is 3. 3 times 7 is 21. X minus 48 equals 24. So we know that something weird's happening here. Our x's cancel out. So we have no x's left. And we have this right here. This should look a little bit familiar. We did this earlier in the year in chapter 1, where we got an untrue statement. So if you're solving a system of equations and you get a statement that is not true at the end, okay, so an equation that doesn't actually equal each other, left and right side, then since this is not true, what that means to us in terms of the lines crossing is that the lines don't cross. Which would mean there's no solution. And think about what type of lines that don't cross are called. They're called parallel. So if you get an untrue statement, the lines don't cross and they're called parallel. If you would get a true statement, like 24 equals 24, or 1x equals 1x, something like that, that is a true statement. And you would have infinite solutions, which means the two lines would be the same line, and they'd overlap each other everywhere. So an untrue statement means I have no solutions, and a true statement means that I have infinitely many solutions. So we're actually going to skip this word problem, and we're going to, I know, everyone gets excited when we skip word problems, and we're going to look at elimination as our next example. So elimination means that I want to get one variable to go away in both equations. So I'm going to give you a pretty easy example. And this is what they tend to give you when you're in like baby math in Algebra 1 or pre-algebra. They give it to you nice and perfect, okay? Nothing ever is this easy. But I'll just show you the basics here. So when we have elimination, in the United States, we mainly teach it that you want the same number, like number 1, opposite signs. And then we add the systems together. In a lot of foreign countries, they subtract the systems. So you do it the way you learned, I don't mind. So if we know this here, if we add the systems the way they are, the y's will cancel. That's what we want. And then we add 5x, 25, x is 5. And then substituting into either equation, I'll just use the top one, 2 times 5 plus y equals 9. That's 10 plus y equals 9, or y equals negative 1. So again, that's the ordered pair where the lines would cross. Okay. We'll look at one more example that's kind of a medium level difficulty. And when you come in, whatever day that is, Monday of next week, we're going to practice doing some more difficult examples and some word problems. So negative 2x plus y equals negative 9, and 3x plus 4y equals negative 14. So when you're looking at the variables x and y, if you wanted to cancel the x's out, you would want to make them both 6s, one negative 6, one positive 6. But it's going to be easier if you choose to cancel the y's. We have a positive 4y here, which means in order to cancel it, we want to multiply everything in that top equation, both sides. Sometimes it thinks I'm making a shape. It's a little crazy. We want to multiply both sides of that equation by negative 4. So it becomes positive 8x minus 4y equals 36. And then we didn't do anything to this equation. And now if you notice, we have opposite signs. And when we add the systems, they cancel. So we get 11x equals 22. And we get x is 2. And when you look at the original two equations, I think the top equation is easier to work with to find y. So substituting in 2, that's negative 4 plus y equals negative 9. Y is negative 5. So we get the ordered pair, negative 2. I'm not sure where I got negative 4 from. 2 comma negative 5. And that would mean on the graph, this is where the two lines cross. So these lines would not be parallel because they have an intersection point, and they wouldn't be the same line because they only have one intersection, not infinitely many intersections. So lines can either cross one time, no times, or infinitely many times. Okay? So your homework will be the following problems. Just a couple for the day you come back on Monday. Page 146. I would like you to do 14 and 15, just a couple to practice. Those are substitution. And for elimination, I would like you to do, let's see here, how about 34 and 37. And then when you come in, we'll practice a little bit more, maybe some decimals, couple fractions, and some word problems, okay? You know you're always welcome to email me if you have any questions, and I hope you have a good day. Thank you.